Hi students, welcome to Darsana YouTube channel. I am Samson SS discussing Neet 2020 Physics Custom Paper. Darsana Academy, an entrance coaching center run by CMI Catholic Fathers with 30 years of excellence. So now we can move with at first the physics question paper analysis. If we just go through the 2017, 18, 19, and 20 question paper, the students are blessed with a very good, so easy question paper. But keep in mind, the trained students only can crack 45 out of 45. We are so much glad to say one thing. The 100% of the questions are coming from Darsana material, our comprehensive material. So the special thanks to Darsana team. So if you just go with the chapter-wise analysis, if you just go with the +1, look, 3 questions are coming from the first chapter, and the 2 questions are coming from the system of particles and rotational motion. And see, from the second volume of +1, see the kinetic theory of gases with a minimum content with the 3 questions. And from the second year, first volume, the more questions are coming from current electricity, but so easy questions. See, then we can move with the second volume of second year. See, the most important one become the electronics and also the optics with 4 questions and the modern physics with 5 questions. So in total, we can think with one important concept, so easy questions, but the trained students can crack all. So we can go with the first question. Say, light with an average flux of 20 watt per centimeter square. So it is given the power, that average flux means that power by area. So that is nothing but the intensity is given. So that is equal to 20 watt per centimeter square. Now you can convert it into meter. So 20 by, yes, 10 to the power of -4, that much meter square. So we can say as 20 into 10 to the power of 4 falls on a non-reflecting surface at normal incidence having the surface area that is given as A equal to 20 into centimeter square. Have it convert into meter square. The energy received by the surface during the time span of 1 minute. Look here. We need to find energy. You can just define what you mean by the intensity. The intensity is nothing but equal to the energy transferred per unit time per unit area. So our aim is to find what is the value for E, and hence E take the value equal to I into T into A. That is equal to that I, the intensity is given as 20 into 10 to the power of 4 into the time that is given as 1 minute. So have it converted into second. So into 60 into area, it is given as 20 into 10 to the power of -4. So here the 10 to the powers cancel there. Then 2 into 6, 12 into 2, that is equal to 24 into 10 to the power of 3 joule. So we can quote the answer as the third one. A good question from electromagnetic waves. So we can move with the next one. Number 47. A simple question from transistor, the semiconducting physics. For transistor action, which of the following statement is correct? So, which one is correct? The first statement, the base, emitter, and the collector regions should have the same doping concentrations. Look, so if you just consider the, yes, that emitter, base, collector. See, if you just analyze the doping concentration, the emitter that is said to be the source of charges, and hence the doping concentration for that emitter is said to be greater compared to the doping concentration of collector, then the least concentration with that base. So that is the strategy. So, and here it is, have the same doping concentration, it is wrong. And then the base, emitter, and the collector regions should have same size. No, you know, it is the third part is said to be collector. Have it collect. So all the energy, the heat energy produced or dissipated in that region. So that is the very important concept. So the area should be so high, and thus from the source that charge carriers should enter into the collector. That will possible only when the base it should be so small. So that statement is wrong. So we can say the width of that emitter that is got greater compared to the width of collector is greater compared to the emitter, that is greater compared to the base. So we can move with the third stadium, and both the emitter junction as well as the collector junction are forward biased. For an NPN transistor under consideration, and keep in mind that always that emitter base junction that is considered to be as input, that is always forward biased, and we are taking the output from the collector emitter configuration. So, and hence that collector junction is always reverse biased. So that statement is wrong. So the answer should be 4. The base region must be very thin and lightly doped one. So the 4th one is the answer. So we can move with the 48th one, a simple graphical question from current electricity. Which of the following graph represent the variation of resistivity with the temperature T for copper for a material? So what about the first material? Yes, it is for the alloys like nickel material. So, you know, for a copper, for a metal, while increase in temperature, its resistivity should increase. That is a very important point. So that is satisfied with the third choice. So 3 is the answer for 48th question. So we can move with the next one as 49. Yes, we are so glad to give one idea, very important one. In the last JMA entrance examination, so these are the person with greater than 99% scores. So special congratulations to Darsanites and the Darsana team members. So a special clap to every Darsana team members because of a very good result, and see the keen result. So we are giving a lot of aspirants with the greater than 800 scores. So special congrats to our team members and also all the students. We can move with the question number 49. In a certain region of space with oleum, that oleum is given as the 0.2 meter cube, the electric potential is found to be 5 volt. So the potential, so the volume, that potential is found to be the 5 volt throughout the magnitude of electric field in this region. So we know the special concept, how to relate between the electric field and the potential. We know the electric field is said to be the negative gradient, the negative of the potential gradient. It is the very important one. In this region, it is given that electric potential is said to be, yes, constant. It is given as 5. that means that dV should equal to 0. So that is the very important one. So that we have to say the electric field should got the value as equal to 0. It is a good concept, a good question from electrostatics. So we can move with another one from the part of semiconductor logic gate. Look here. For the logic circuit, the truth table is, so we can just draw the truth table for the circuit. Yes, ABY. So at first we can put that 0, 0 for AB. Yes, 0, 0. Look here, not good. So that should be 1. That should be 1. So here the OR, it becomes 1. So not, it becomes 0. So we can give us 1, 0, 1, 0. So not, it becomes 0, 1. So it becomes 1 here. And again the output becomes 0. The same case we have to take for if A is equal to 0 and B equal to 1. And if we just give the value for 1 and 1, 1 and 1, it becomes 0, 0, 0, then it becomes 1, that is the output. So if we just go through it, so we can get the choice as the first one. A simple question. The students who knows the theory very well, the student with, who is said to be so attentive, can crack the questions so easily. So that is the structure of all the questions. So we can move with the next one with the question number 51. A 40 microfarad capacitor. So the capacitance is given as 40 microfarad is connected to a 200 volt potential. So it is given the VRMS is equal to 200 volt, 50 hertz is the frequency that is given as 50 hertz. The RMS value of current in the circuit is, it is an AC network, and hence we can say that IRMS, it is equal to that VRMS division by, yes, the impedance, but here only the capacitor, we have to say the capacity reactance. So that is equal to, we know the capacity reactance, take the value as equal to, yes, 1 by omega Z. Omega is what? As the 2 pi F into the capacitance Z. So you can just put the values. The VRMS that is given as 200 into 2 into as 3.14 into the given the frequency as 50 into. So we need to give the value of C as 40 into 10 to the power of minus 6. So on calculating, and you get the value as equal to the third choice as 2.5 ampere, 2.51 ampere. So 3 is the answer. A simple question from AC. So now we can move with question number. Look, yes, after Neet 2020, we are starting our next new repeaters batch from this Wednesday onwards. So that is the speciality. So, and we are taking our IIT batches from after few weeks. So the students wants to, at first we are continue our classes in online. After that with our offline classes. So with the good material, with the good sessions, with the good library, so everyone can join. So see, number 52, a good question from Kennedy theory. A cylinder contains hydrogen gas at a pressure that is given as P is equal to 249 into 10 to the power of 3 Pascal. At a temperature, it is given as 27 degrees Celsius. In terms of absolute temperature, it becomes 273 plus 27. It becomes 300 Kelvin. It's a density, we have to find it. We know the simple relation, the gas relation, we can say as a P is equal to nRT. We know the number of moles, we can take as a, yes, the mass division by the molecular mass into RT. So we can substitute for that oleum. So that is equal to mass by density. So our aim is to find that density. So we can get the relation for rho is equal to P, the pressure, the molecular mass division by that universal gas constant into the absolute temperature. And we can substitute for that the pressure that is given as 249 into 10 to the power of 3 into the molecular mass of hydrogen as 2 into 10 to the power of minus 3, that division by that 8.3 into the temperature that is given as 300, then you get the value is equal to, yes, we get the answer as 0.2 kilogram per meter cube. A good question from our, and see the next question. Yes, 53. Yes, simple question from units and dimension and measurements. Taking into account of the significant figures, what is the value of 9.99 minus 0.0099 on subtracting? And see the case. Yes, you get the answer as 9.9800. Yes, 10. Yes, 1, 0. Yes, 8, 9, 9. But scientifically, we know in the subtraction process, the answer should retain with, yes, minimum decimal places. That is a rule. So in this case, here it is 2. Here it is with the 3. The answer should be with the 2 decimal places. So you get the answer as 9.98. So simple question. And maybe that question is from our comprehensive material. So the proud to say all the concepts and questions are coming from our DPP, Darsana DPPs and Darsana MCQs. That is a speciality. The direct question is waiting from kinetic theory of gases. The mean free path for a gas with molecular diameter d and number density n can be expressed as with a simple direct relation as 1 by root 2 n pi d square. So that is a good question. And we can go with the question number 55. An iron rod of a susceptibility that is given as the susceptibility, magnetic susceptibility is given as 599 is subjected to a magnetizing field of 1200 ampere per meter. The permeability of the material of the rod is, so we are so much comfort with the relation, we can just define that relative permeability, that mu r is equal to the permeability by the permeability of free space. So we need to find what is the value of mu is equal to the mu 0 times of mu r. We can relate that mu r with the susceptibility by the relation as 1 by 1 plus km. So we know the equation for mu 0 as yes, 4 pi into 10 to the power of minus 7 into 1 plus, yes, we need to substitute the value for km as 599. So that is equal to 4 pi into 10 to the power of minus 7 into s 600. So on solving, you get that value as equal to as 2.4 pi into 10 to the power of minus 4. So we can take the choice as the first one. A good question from magnetism and matter. And question number 56 from electrostatics. A short dipole has a dipole moment. So that is given as P, take the value equal to 16 into 10 to the power of minus 9. that much coulometer. The potential due to the dipole at a point. So suppose we are representing that dipole with a minus q charge. Yes, a plus q charge. Suppose the center is there at a distance of 0.6 from the center of the dipole, situated on a line making an angle of 60 degree with the dipole axis. So see, suppose the point under consideration at a separation 0.6 meter and makes an angle of theta. So have to find what is the potential at the point P. Take the value as equal to, yes, 1 by 4 pi epsilon 0. That is a P cos theta division by r square, a good expression. So we know the 1 by 4 pi epsilon 0, take the value as 9 into 10 raised to 9 into that dipole moment as a 16 into 10 to the power of minus 9 into as a cos as 60, take the value as 1 by 2 by that r square as a 0.6 into 0.6. So that is equal to as a 9 into 16 10 to the power minus 9 and plus 9 cancel. That division by, yes, 6 into 6 as a 36 into 10 to the power of minus 2 into 2. And after solving, you get the value as a 200 volt. So that is a good question. Then we can move to the next one as a 57. A good question from gravitation. So here, a body weighs 72 Newton on the surface of the earth. So we have to say that AmG0, that is given as 72 Newton. What is the gravitational force on it at a height equal to half the radius of the earth? So from the radius, at a height is equal to half the radius. Suppose here the gravity is g dash. Our aim is to find Am into g dash. So that is the value. So that is equal to, we know the value. Suppose from the center, suppose we are taking that r value, we can say that gm division by that r, small r is nothing but equal to r plus h square. But we know the simple concept as g0 as capital Gm division by r square. So you can simply substitute in place of Gm as a capital Gm, take the value equal to as G0 r square. So we can just substitute for that m into G0 r square by, yes, you have to just substitute the value for h. It is given as nothing but equal to r by 2, that much square. And it's given that mg0 as 72 Newton into r square, that division by, yes, 3 by 2r the square. So that is equal to that r square cancel. That is 72 into, so 2 square, it becomes 4 division by 9. And on solving, you get the answer for the 57th one with the value as a 32 Newton. So that is the speciality. So 2 as the answer. So a good question from gravitation. Now the number 58. The solids which have the negative temperature coefficient of resistance. You know the value, the coefficient of resistance, the plus value, minus values, 0. When temperature is increases, if the resistivity goes on increasing, we have to say with the positive value, otherwise negative. The good examples as insulators and the semiconductors, a special but simple conceptual question. Number 59. So the students, please share this information. Darsana, the only team members from Kerala, they are giving live classes to students, the +1, +2 aspirants. So we are giving the tuition plus entrance, Neet or JE classes of all the +1, +2 aspirants. So please share this information to your relatives. So Now the 59th question, a good question from modern physics, the photoelectric effect, but a tricky question. The light frequency 1.5 times the threshold frequency is incident on a photosensitive material. What will be the photoelectric current if the frequency is halved? The intensity is doubled. We can roughly think that the current is purely depends upon the intensity, but here the incident frequency should have higher value compared to the work function. So that is the very important one. But students, here the first one, the light intensity 1.5 times of the threshold frequency is incident, but the frequency is halved, that 1.5 by 2, the less than nu zero. So when the frequency decreases to less than nu zero, then there is no chance for photoelectric effect. So 0, that is the answer. A good question. Now, number 60. A good question is waiting from SG. A series LCR circuit is connected to an AC voltage source. So, an inductor, capacitor, a resistance network. When L is removed from the circuit, so the L is removed, so it becomes that RC network. So if we just analyze the Phasor diagram, it is the very important one. See, the current through the resistor, the potential through the resistor, we can mark the like that. And here the capacitance is there, the voltage across the capacitance is like this one. So we have to find its value. Z, this is the 5. So suppose we needed to find the value of tan 5. So that is nothing but equal to, yes, so we can say that, yes, VC division by that VR, or XC division by R. So that is important. But it is given as pi by 3. So pi by 3. The tan 5 is equal to pi by 3. And in the next case, instead of L, C is removed. Then it becomes, yes, LC network, LC network, LR network. There R is there. Then at that case, we have to, yes. Then if we take the value, the 5 value. There also that tan 5 take the value as, tan 5 take the value as, that is equal to XL division by R. Again that value are pi by 3. That means, so the tan of 5 by 3, the pi by, that angle is the same. For the that case, 5 by 3 angle is given. That means that XL should equal to XZ. That means we have to say it is under resonance. That means it becomes purely resistive network. For a purely resistive network, the phase difference between the voltage and the current becomes 0. So that phase difference becomes 0. That means the power factor, that cos 0 become 1. So 3 as the answer. A very good question among that 45. So as students, see, now I am welcoming Mr. Rajiv Ranjan from IIT Varanasi to continue the session. So welcome, sir.
Thank you, sir. Hello, dear students. Once again, I welcome all of you at this session, and I will continue the remaining problem. So you can see here this question. Yes, 61st question here. There is a spherical conductor and radius is given 10 centimeter and charge on a spherical capacitor is given. Okay. So here you can see charge is given. Yes. So this is charge given. Let us suppose there is a spherical conductor here and radius is 10 centimeter and charge q is given, value is 3.2 into 10 to the power minus 7 coulomb. So you have to find at some distance r outside this conductor what will be the electric field. Let us suppose this point is p. So here at point p what will be electric field? So this is very simple question, but again very conceptual. You know whether it may be solid or hollow. Okay. So electric field will be kq by a small r square, not the radius. It is simply you have to consider this as a point charge at the center. So k value is given. This is nothing but k. So it is 9 into 10 to the power 9 and charge is 3.2 into 10 to the power minus 7 and r is given 15 centimeter. That means what? 15 square and it is in centimeters, so 10 to the power minus 4. So if you will solve this, you will get here electric field at this point P will be 1.28 into 10 to the power 5 Newton per coulomb. So our answer will be second one. Hope so you understand this. So basic concept is that you have to consider this as a point charge and you have to find electric field. Okay. So next problem. This is very simple problem. Here position vector is given, means r is given. R is given position vector. This is nothing but vector r and force is given. Force. So force is 3 j cap and r is 2 k cap. You have to find torque. You know torque is what? R cross F. So R cross F is simple. It is a cross product of two vectors and here R is 2 k cap into 3 j cap. And probably you know the cross product of two vector, and since it is very simple one, you should know this one. Here let us suppose vector I, vector j and vector k, these are unit vectors. So put arrow sign in a cycle and always you have to move along the arrow, then you have to take plus, and if you will move in opposite direction you have to take minus. So here k cross j cap, k and j, 2 into 3 is what? 6 into k cross j cap. So this is what? Vector product, and k cross j is what? Opposite, means minus. K cross j means minus I, so it will be 6 I cap. So simple question, you should know this simple technique and you can easily solve this problem. So next problem. Okay, this is the 63rd problem. Here you can see charge particle having drift velocity. So Vd is given 7.5 into 10 to the power minus 4 meter per second, and electric field is also given here 3 into 10 to the power minus 10 volt per meter. So let us write electric field magnitude is 3 into 10 to the power minus 10 volt per meter, and you have to find mobility. So you know this is question from modern physics, simple problem. So you know that drift velocity is what? Mobility mu into electric field. So from here you can find mu will be Bd, means drift velocity, divided by E. So very simple problem. You can see here 7.5 into 10 to the power minus 4 divided by 3 into 10 to the power minus 10. So this is how much mobility will be 2.5 and minus 4 plus 10. So it will be 10 to the power 6. Okay. So mobility will be 2.5 into 10 to the power 6. Means option second is correct. Clear? Very simple problem. So let's move to next. Okay, this is the question from ray optics, geometrical optics. It is little technical problem. Here some assumption is required. Question is, you can see a ray is incident at an angle of incidence I on a surface of a small angle prism. A small angle prism is very important line. With angle of prism is given A, and emerges normally, means it will come out from the secant surface. Normally means what? Angle of emergence will be 90 degree. So let us draw a figure here. Let us suppose this is a very thin prism. Angle is A, and draw normal here. Say the incident ray is this one, and angle of incidence is I. Okay, but when it enter prism, it will come out from the prism normally, means perpendicular to this face surface. Okay, so it will be like this one. This angle will be 90 degree. Say this angle R, and here refractive index is given mu. So we can apply Snell's law, but before that we should know R, because we have to find relation between I, A and mu. Means we have to find I, angle of incidence. So how to find? See, you can see this angle is R, this is 90 degree, this is J. So this plus this angle will be what? 90, because total summation of all the angle is 180. So this will be how much? 90 minus A. Clear? And see, this is complete right angle. Okay? Means R plus 90 minus A is simply R. Sorry. This is simply what? 90 degree. This angle plus this angle is what? 90. So this will be cancelled out. Means what? R equals to A. So this is very important relation. It is useful to find I, angle of incidence. So what will be this? See, mu1 sin I equals to mu2 sin R. Very simple formula, you know. So mu1 is how much? 1, air, nothing is mentioned here. Sin I. So this is sin I mu sin r. Sin r is what? A. So this relation you will get here. So it is given very thin prism. So for very thin prism, you can write sin I equals to y and sin A equals to A. Approximately we can write, because thin prism means angles are very small. So we can do this approximation. So here you can write I equals to mu into A. And this was our simple question with this approximation. Okay. So I will be mu into A. So option third will be correct one. I think you got this. Okay. So let us move to the next problem. So yeah, 65 question. See, it is given the quantities of heat required to raise the temperature of two solid copper spheres. Means there are two spheres of copper material and it is solid, not the hollow one. And R1 and R2 is given. R1 equals to 1.5 R2 and delta T is given 1 Kelvin. You have to find the ratio Q1 by Q2 to raise the temperature of each sphere by 1 Kelvin. So let us suppose we have one sphere and this one second sphere. Here radius is R1, it is R2. And relation is given R1, both are of same material, means what? Density will be same, rho. R1 is 1.5 R2 and delta T is given 1 Kelvin. Okay. So basic formula you know, Q is what? M is delta T. See, specific heat for both is same. Delta T is also same. Only this mass is changing, and we can write Q equals to mass is what? Density into volume. So density 4 by 3 pi r cube into S into delta T. Clear? So we can say Q is proportional to only R to the power 3 because all remaining are same for both the sphere. So from here you can write Q1 by Q2 is nothing but R1 by R2 to the power 3 and it is what? 1.5 means what? 3 by 2 to the power 3. So it will be 27 by 8. So which option is correct? This one first. Okay. So simple problem. So let's move. Okay. It is very common thing. There is a uranium isotope and there is bombardment of one neutron. So it will split in krypton and three neutron plus one another thing will be what? Krypton plus barium. It is very common reaction. Probably you remember this. Otherwise, you can write equation, very simple equation. Like here you can write uranium 92, 235 and bombardment of neutron. Okay. So 0, 1. It result in product will be krypton. It krypton 36 and 89 plus 3 neutron. 3 neutron means what? 0, 1 plus another compound, say Y. Okay. ZA. So very simple reaction. So you can write 92 plus 0 equals to 36 plus 0. Okay, so 36 plus 0 plus z. So from here z will be how much? It will be simply 56. Next you can balance mass numbers. So 235 plus 1. Neutron has mass 1. Mass number 1 equals to 89 plus 3 into 1 3 plus y. So from here you will get y equals to 144. So you can find, again, first option is correct. Though it is very common reaction, you should remember this. Okay. So next, yeah, very simple problem. Verbally you can reply. Otherwise you can find here. Let us suppose equation of simple harmonic motion is a sine omega t plus phi. Okay, they are asking for phase difference between displacement and acceleration. Very common. If you will differentiate this, you will find this will be what? A omega cos omega t plus phi. Okay. So acceleration will be what? Again differentiate minus A omega square sine omega t plus phi. Clear? So simply you can take this minus here. So you have to add pi. Sine pi plus theta is minus sine theta. So here you can write a omega square sine omega t plus phi plus pi. So what is the phase difference? Difference between this term and this one. So simply pi. So option 1 is correct. Clear? So simple. Okay, next. Okay, this is very conceptual problem based on Wheatstone bridge. Means meter bridge is similar to Wheatstone bridge. Okay, so let us see here. Let us suppose this is part of Wheatstone bridge. Means bridge, meter bridge. This is the meter bridge part of rod. Say resistance per unit length is lambda ohm per meter. It is very simple setup. Here we are attaching this with a battery, and there is one arrangement to find unknown resistance here. Say this point is A, this is B, and this one is C. Okay. So if you want to find any unknown resistance, you can easily find. There will be galvanometer based on null deflection. Okay, this is your jockey. So this length say x1, say this is x2, and we have to put resistance where between A and B. Means here it will be C, and here resistance is given how much? 10 ohm. This resistance 10 ohm. Now we can read the problem. A resistance were connected in the left gap, this side left gap, in a meter bridge balances a 10 ohm towards right gap, and this length ratio is given 3 is to 2. 3 is to 2. So this will be what? Resistance of this portion will be 3 lambda, and here this portion 2 lambda. Okay. So if you draw this as a meter bridge, so it will be like a Wheatstone bridge, balanced Wheatstone bridge. Okay. This is Here galvanometer will be here. So very simple setup. This R resistance you have to find. This is given 10 ohm. So this x1 is what? 3 lambda, and this one is 2 lambda. So hope so setup is clear. Right now it is a very simple problem. R into 2 lambda, 10 into 3 lambda. So R into 2 lambda, 10 into 3 lambda. So from here you can easily find R resistance, unknown resistance. This will be how much? 30 by 2, 15 ohm. Okay. So what is the next part? If length of the this wire is given 1.5 meter, so you have to find what will be length corresponding to 1 ohm resistance. See, total resistance is 15 ohm, and for this 15 ohm, length is given 1.5 meter. So for 1 ohm, length will be how much? 1.5 by 15. So simple. So it is 0.1 meter, and 0.1 meter we can write 1 into 10 to the power minus 1. So option 2 is correct. So this was very conceptual problem. Okay, this is also simple problem. You can see here it is given a capillary tube of radius r is immersed in a water, and water rises to a height of h. Now this capillary tube was replaced by another tube of radius 2r. Okay, and initially mass of the water inside capillary tube was 5 gram. So you have to find in the new setup what will be the mass of water inside capillary tube. So there are two setup. Let us suppose this was first part, this one second. Here there is a tube and radius is r. There is another setup here. Radius is 2r. Height of water level inside the tube above this surface is given h. Okay. So next here again same setup. So height is unknown. Say h2. Okay. So you have to find what will be the mass of water in this second tube. Say mass is m2. Clear? So how to find this? Very simple problem. You know that rise in height of water or liquid inside capillary is what? 2t cos theta by r rho g. Okay. So you can easily find here the see T is what? Surface tension. Will be same for both because water and glass system is there, and cos theta will be same. R is different, density is same, G is same. So from here you can write H1 by H2 equals to R2 by R1. So R2 by R1, and R2 is what? 2R. So 2R by R is simply 2. Clear? So next is mass. So M1 by M2 or M2 by M1 will be what? Mass is what? Density into volume. Density will be same. Volume is what? Cross-sectional area into height of liquid inside the tube above the water surface. So it is pi r is 2r square h2 divided by again pi, but this time for this one r square h1. Okay, so m2 by m1 will be 2 means 4 into h2 by h1. So h2 by h1 from here, what will be reciprocal of 2 is 1 by 2, so it is 2. So this is the ratio of mass. We have to find mass. So m2 will be 2 times of m1, and m1 is 5 gram, so answer will be 10 gram. So third option is correct. Hope so you understand this. So next, so very important message for you. Here we are running classes for long-term student for plus 1 and plus 2. Along with your board exam, you can prepare here for JEE and NEET and also KEM exam. If you are interested, you can join or you can convey this message to your friends or family members. All the faculties are very experienced here. So this is information for you. So let us move to the next problem. Okay, next problem 70. So question is given, the ratio of contribution made by the electric field and magnetic field components to the intensity of an EM wave you have to find. This problem is related to electromagnetic wave, and you know that intensity is what? Simple. I is what? U average into C, where U is energy density. Energy density. So they are asking for contribution of electric field and magnetic field in the intensity. And electromagnetic wave is made up of consist of both electric field and magnetic field. So very simple. U average you can write if electric field contribution due to electric field, what will be U average? Say U E. So it is simply half epsilon naught E square. Half epsilon naught E naught square. This is the peak value. And contribution of magnetic field will be simple. UB will be half B naught square. B naught is what? Magnetic field intensity divided by mu naught square. Okay. So you have to find the ratio of both. So you should know this E naught is what? Simply C into B naught, and also C equals to 1 by a square root of mu naught epsilon naught. Okay, mu naught epsilon naught. So ratio will be what? U E by U B will be simply E naught square, half half will be cancelled out, epsilon naught E naught square by B naught square divided by mu naught. So from here it will be epsilon naught mu naught. You can write E naught is C into B naught. So C square B naught square divided by B naught square. So what will be this? Cancelled out. And C. This is C equals to 1 by root under mu naught epsilon naught. So if you square on both sides, you will get c square and multiply this term here towards left, mu naught epsilon naught equals to 1. So very simple, this will be cancelled out and this term is simply 1. So ratio will be 1. So what will be in answer? Second option is correct one. Okay. So this is an important problem, but again easy and fundamental. Next. Okay. This is the question based on Young's double slit experiment. Here, fringe width initially given, and again you have to find with some changes in setup. So what to do? Let us draw setup. Always try to draw setup here. Let us suppose this is a screen and there are two sources separated by distance d. Okay, this is S2, this is S1. There are two sources and this gap is given capital D. Okay, let us suppose. Now at this point beta is fringe width is what? Lambda d by d. Clear? So you have to find beta dash when this separation d is changed to d by 2 and capital D as a 2 times. Okay, clear? So simply put the value, lambda will remain same, d is 2d and this is d by 2. So what will be new fringe width? 4 times of initial. So simple problem, only you should know the setup figure. So always along with formula you should know some derivation and setup. So it's very simple. 4 times. Third option is correct. Okay. Move to next problem. It is given, so there is a solenoid and length is given. Length is how much? Length is 50 centimeter and number of turns is given. Capital N is 100. Current is also given 2.5 ampere. So you have to find what will be magnetic field at the center of the solenoid. So it is very simple problem based on formula only. You know that at the center, magnetic field is what? B equals to mu naught Ni. This N is number of turns per unit length. So what will be N? Capital N by L. So it is 100 divided by 50 centimeter is what? 0.5 meter. Clear? So put the value simple. Mu naught is what? 4 pi into 10 to the power minus 7 and number of turn 100 divided by 0.5 into I 2.5 ampere. So what will be answer? So it will be, from here you can see 25 this side here. So it will be 6.28 10 to the power minus 4, or you can calculate here. This is 4 pi and this 250 means 100 10 to the power minus 5 into 25 by 0.5 means 250 by 5 means 50. So here it will be 50. So it is 2 200 means 2 pi into 10 to the power 20 and 10 to the power minus 3. So it is 6.28 into 10 to the power minus 3. Okay, 72. So option, okay, just a minute. Okay, this is 2.5. We have here it is 2.5. So it will be 10 to the power minus 4. So this is only 5. Okay, so this will be 4. This is 5, this is 4. So option first is correct. Okay. So next problem. It is a simple problem of kinematics. It is given a ball is throwing from the top of a tower and velocity is given downward 20 meter per second. And when it will reach at the ground, velocity is 80 centimeter per second. You have to find height of the tower. So simple problem. Let us suppose this is a tower of height h. Here velocity of ball is 20 meter per second and here it is 80 meter per second. You have to find this h. So simply v square minus u square equals to 2s. So v is what? 80. So 80 square minus 20 square into 2. A is what? Acceleration due to gravity 10 already given here into h. So what will be h here? 6400 minus 400, 6000 divided by 20. So it will be 300 meter. So option fourth one is correct. Okay. So let us move to the next problem. It is very simple problem. Bohr model is applicable to what? Hydrogen or hydrogen-like atom. So four options are given. This one is applicable here. Singly ionized helium atom also applicable. Deuteron also isotopes of okay hydrogen. So it is also okay. Last option singly ionized neon atom. No. For this Bohr model will not be applicable. So means this option is correct. They are asking for which is one is not applicable. Okay, simple problem. So this is the last problem from my side. You can see the average thermal energy of a monoatomic gas, a single particle they are asking. So it is simply 3 by so what is the energy? Simply E equals to F by 2 kT. K is what? Boltzmann constant and F is degree of freedom. And for monoatomic gas, it is simply 3. So answer will be 3 by 2 K B into T. So which option is correct? Second one. Okay. Hope so you understand this problem. So for further discussion, I am inviting Mr. Kitty Lals. Okay, sir.
Hello, everyone. Okay, myself Kitilal BS. Welcome to our YouTube channel. Okay, I'll continue with the remaining questions in the physics part. Okay, look at the 76th question. Two particles of mass of 5 kilogram and 10 kilogram respectively are attached to the two ends of a rigid rod of length 1 meter with a negligible mass. So that rod of length 1 meter has a negligible mass. You are asked to find out the center of mass of system from the 5 kilogram particle is nearly the distance of. So from that 5 kilogram mass, you have to find out its the position of the center of mass. So it's a question from the rotation dynamics of system of particles. So consider the say x and y axis, and I assume that I'm assuming that the rigid rod is kept along the x-axis, is one end at the origin. Okay, and at that origin we are going to keep that 5 kilogram mass. So this is a 5 kilogram mass. At the other end, at 1 meter length, we have got 10 kilogram mass, and the length of the rod is given as 1 meter also. Okay, and you are asked to find out the center of mass position from the 5 kilogram mass. That's why I deliberately kept that 5 kilogram at the origin. So you have to find out the position of the center of mass. It will be somewhere here. You put it as xcm. So the formula will be, what's the formula for xcm will be is equals to m1 x1 plus m2 x2 divided by m1 plus m2. So here we take the m1 as 5 kilogram and m2 as 10 kilogram. Okay, so m1, the 5 kilogram is kept at the origin, so that x1 will become 0, and m2 is 10 kilogram and x2 is 1, divided by total mass will be 5 plus 10. So simply it will be 10 divided by 15. Okay, so 10 by 15 will be 2 by 3 in meter, but here are converted into centimeter. What will happen? You are just converting, multiply with 100, so it will be 200 divided by 3. It will be 67 point. It will be actually 66.66. It will be continuing recurring decimal. It will be approximately 67 centimeters. So option 3 is your answer. Okay, moving on to next question. Look at that. It is a question from the chapter wave chapter. In a guitar, two strings A and B made of the same material are slightly out of tune and produce beats of frequency 6 hertz. When the tension B is slightly decreased, the beat frequency increases to 7 hertz. If the frequency of A is given as 530 hertz, you are asked to find out the original frequency of B will be. This question will be, maybe you are done the question with the tuning fork. The net tuning fork will be waxing, frequency is going to decrease. If you are filing it, frequency is going to increase. It's a similar problem only. Instead of tuning fork, we have got a guitar string. That's only the difference. Okay, so assume that the frequency of A is given. So you assume it as a standard tuning fork. Okay, frequency tuning fork is given as 530 hertz. Okay, 530 hertz, and you are asked to find out the frequency of B. So, and if initially it is producing the beat frequency of 6, means new B has only 2 chances. Okay, it will be 530 plus 6, that is 536, or it can be 530 minus 6, it will be 524. Okay, so there will be only 2 chances of option 2 and 3 will be the possible answer, but we don't know which one is the answer. Okay, for that you know to decide whether it is 536 or 524, you have to go through the remaining part. Look, frequency of a transverse wave in a string is given by 1 by lambda into root of T by mu, where lambda is the wavelength, T represents the tension in the string, and mu represents the mass per unit length. So here frequency will be directly proportional to root of tension. Okay, here you look, here what happens to the tension B? The tension of the B is being increased, so the frequency is also going to increase. So okay, tension of B is going to be decreased, so the beat. Okay, the frequency of the B is going to decrease, but beat frequency is going to increase to, right? It was 6 before, now it is 7 hertz. So which one are you going to choose? Okay, which one you have to prefer for that? Either it is 536 or 524. Okay, so you just think about it. Just to use your common sense. Okay, again you have to get 7 hertz. So the 530 is the frequency of A. is the frequency of A. Okay, only if you choose the frequency of B as 524, and when you decrease the tension, what will happen? The frequency of B is going to decrease. So assume that this 524 is going to decrease us to 523. Now, if you beat A and B together, what will happen? Between 530 and 523, we can have a 7 hertz beat. So the option has to be, the frequency of B has to be 524. Okay, because just a logic, you can get that answer. Okay, moving to the next one. Look at it. Here's a question from thermodynamics. Look, two cylinders A and B of equal capacity are connected to each other via a stopcock. And A contains an ideal gas at a standard temperature and pressure. B is completely evacuated. The entire system is thermally insulated, so they are not exchanging any heat between the system and the surroundings. The stopcock is suddenly opened. So that's our keyword. Here it is suddenly. It will be suddenly opened. Okay, if the procedure, that process is in a thermodynamics, the process is happening suddenly, that process has to be adiabatic. Not to become its isothermal, the process has to be happen very slowly. We call it as a quasi-static process. Here it is suddenly opened, means that process has to be adiabatic process. Okay, now the next one, look at it. Now we are going to electrostatic question. Look, the capacitance of a parallel plate capacitor with air as a medium is 6 mu f. With the introduction of a dielectric medium, capacitance becomes 30 microfarad. Capacitance being increased. The permittivity of the medium. So you are asked to find out permittivity. You are not asked to find out the relative permittivity. Okay. So C air, you know it is epsilon 0 A divided by D. C medium will be epsilon 0 epsilon R epsilon 0 A by D. So for relative permittivity will be simply C medium divided by C air. So it will be 30 divided by 6. It will be 5. Okay, so here just find out the relative permittivity. Now the permittivity of the medium will be epsilon is equal to epsilon naught into epsilon r. So with that, you have to multiply that answer 5 with the, you know, the value of epsilon naught 8.85 into 10 raised to minus 12 into 5. Okay, so it will be nearly 40. Okay, so your option will be 79. It will be option number 3. You will get it as answer 0.44 into 10 raised to minus 10 coulomb square, Newton raised to minus 1, meter raised to minus 2. Okay, so a rather simple problem, just simple multiplication. Okay, now look, it's a question from your dual nature chapter. Look, an electron is accelerated from rest through a potential difference of V volt. If the de Broglie valence of the electron is given as 1.227 into 10 raised to minus 2 nanometer, it is, then the potential difference you need to find out. So the de Broglie relation lambda is equal to h divided by p. It will become h divided by root of 2m kinetic energy, or it will be h divided by root of 2m q into v. If for an electron, it becomes h divided by root of 2m ev. Okay, so the h, 2, m, and e, mass of the electron, the charge of the electron, other than v is all constant. So you'll get it as lambda is equals to 12.27 angstrom divided by root v. Okay, and here it is given as a wavelength as 1.227 into 10 raised to minus 2 nanometer. It is, so 10 raised to it will be 10 raised to minus 9, 10 raised to, sorry, 10 raised to 9 equals to 12.27 into 10 raised to minus 10 whole divided by root v. Okay, so 1.227, it will become 10 times. So here it will be in the left hand side, it will be 10 raised to minus 11, right hand side it will be 10 raised to minus 9 divided by root v. Therefore root v is equals to 10 square, and v is equals to 10 raised to 4 volt it is. So option number 4 is your answer. Okay, now look at the question number 81. It's a question from properties of matter. Okay, solid part. This is again a direct question only. A wire of length L and area cross section A is hanging from a fixed support. The length of the wire changes to L1. So that it was L1, it changes to L1. When a mass M is suspended from its free end, the expression for the Young's modulus. So it's a rather direct one only. So Young's modulus Y is equals to F divided by A, which we call it as what a stress, linear stress, into delta L divided by L, which is called what a linear strain. Here the only the thing you have to change it is here F will be replaced with the mg, because the weight hanging will be, the mass hanging will be m. So weight the F can be replaced with the mg, and area cross stay A itself. Length will be big L. Only thing you have to careful is delta L is given. So delta L represents a change in length. So here you have to substitute L1 minus L. So or rather a direct question only. Option number 4 is your answer. Okay. Okay, here there's a information. Here you are conducting a integrated batches. Okay, you should just share this information with your friends and relatives, and those who are looking for a better rank in IIT and NEET examination, come and join us, and we'll help you all with the maximum effort that we can provide. Okay, and moving to the next one, 82nd question. Look. The Brewster's angle IB of the interface should be, what is the possible values of Brewster's angle we can take? You know that for air, the refractive index mu is equals to 1. So that's a minimum value. Okay, it's a minimum value. And for a diamond, which has got a comparatively more refractive index, so that almost the maximum refractive index will be around 2.4. Okay, and here the Brewster's law, you know that mu is equals to tan IB. Okay, so tan inverse of 1 will be, you know the value, tan inverse of 1 will be 45 degree, and tan inverse of 1 will be 45 degree, and tan inverse of 2.4 nearly 67 degree. Okay, so the Brewster's angle cannot go beyond that. So the better option will be the Brewster's angle always lies between 45 degree, and it will be greater than 45 degree and less than 90 degree. That is option number 3. Okay. There's a question from Newton's laws of motion NLM. Okay. So look, so there are two masses, two bodies of 4 kilograms, 6 kilogram, and the pulley is being fixed, and it's a frictionless pulley, and the string will be definitely, it will be inextensible string. The acceleration system in terms of acceleration due to gravity you have to find out. So no G, you don't know how to substitute. So assume this is M1 and this is M2. Okay, and the M1G is acting downwards, and M2G, its weight will be acting downwards. Okay, so there will be tension in the string. So there will be tension. The string will be always acting away from the joint, and you have to write what the free body diagram, and you have to obtain the equation. So simply assume that is 6 kilogram is moving down with an acceleration A. At the same time, 4 kilogram will be moving up with the same acceleration. Why? Because they are connected by an inextensible string. So M1 into A will be is equals to M1G, the supporting force minus opposing force. M1G will be acting down in the direction of A, and T will be opposing. And the M2A is equals to, who is pulling it M2 up? It will be the tension T minus M2G. Solving it, you will get the acceleration A as M1 minus M2 into G divided by M1 plus M2. If you know this formula directly, you can directly substitute it. So it will be 6 minus 4 divided by 6 plus 4 into G. So it will be, the answer will be G divided by 5, option number 3. Okay. Then look at the question number 84. Is a rather simple unit and dimension chapter question. It's a stress dimension formula only have to find out. You know the stress is equals to force by area. It will be force divided by area. So force will be ml t raised to minus 2 divided by area. It will be L square. So it will be ml raised to minus 1 t raised to minus 2. So it will be option number 4. Okay. Then next one, again unit and dimension chapter question, the screw gauge. The screw gauge has a least count 0.01 millimeter and there are 50 divisions in a circular scale. Usually screw gauge has 100. Here they are using different screw gauge having only 50 divisions. You are asked to find out the pitch of the screw gauge. Okay, so least count. So least count will be equals to pitch divided by number of divisions in the circular scale. So simply pitch will be equals to what? Least count. It's given as 0.01. What is the number of divisions in the circular scale? It will be 50. So multiplying, you will get it as option number 3.5 millimeter. Okay. Now the next one. Look, 86th question. The energy required to break down one bond in a DNA is 10 raised to minus 20 joule. The value in electron volt. Simple conversion only you have to do it. And this is a question actually in NCERT book. It will be the NCERT page number 27, the work power energy chapter, physics first year, first volume book. It is an example, as an example problem it is given. Here you have to convert energy. You have to convert energy is equals to how much it is? 10 raised to minus 20 joule it is. So just divide with 1.6 into 10 raised to minus 19. So in order to convert into electron volt, you will get the option as a 0.0625 will be the exact value electron volt. Here you can choose an option as option number 3. Okay, so again a simple NCERT question in the work power energy chapter is actually a solved example problem in your book. Okay, in the going to next one, look at the 87th question. Again, it's a simple one. Look, color code. So it's a question from your current electricity chapter. So you know how to find it, that the coding you will be knowing it to B R O Y. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You will remembering it. It will be black, brown, red, orange, yellow, green, blue, violet, green, and white. So how will you find the color code from it? Okay, how will you find out the resistance from it? So it will be the coding will be first color into first color. Okay, that first color and second color into 10 raised to the third color, that much of ohm, and there will be what a percentage of how much it will be the tolerance you have to find out. Okay, so what will be the first color? Yellow. Yellow means the number will be 4. Okay, and the second color will be violet, so number will be 7 into 10 raised to. So it's the first color, it's the second color, it's the third color. Okay, then the third color will be brown, so brown will be 1. So this much of ohm, and for it is gold means the tolerance will be 5%. So answer will be 470 ohm, and it will be tolerance will be 5%. So your option will be option number 4. Okay. Then look at the question number 88. Assume the light of wavelength 600 nanometers coming from a star. The limit of resolution of the telescope whose object has a diameter 2 meters, you have to find out. So it will be again a direct question. So it will be the resolving. Okay, resolving power will be for a telescope. It will be D divided by 1.22 lambda is that relation. And you are asked to find out not the resolving power, limit of resolution. So look, limit of resolution means it will be the reciprocal of resolving power. So it will be 1.22 lambda divided by D, which will be equal to 1.22 into lambda is given as 600. So it will be 6 into 10 raised to minus 7 divided by D will be 2. So solving it will be 3. So it will be something 12 into 3 will be 36, 3.66 into 10 raised to minus 7 radians. Okay. So it's a question from your optical instrument part. Okay. Moving into next one, look, 89%. The increase in width of the depletion region in a PN junction diode is due to. So how can you increase the width of the depletion diode? So what type of connection you have to do it? So assume that it is a consider a PN junction diode. Consider a PN junction. So this part is P, this part is N, and there's a depletion layer is formed. The depletion layer is formed means the P side will be the negative and the N side will be positive, and you are going to connect a battery in a such a way that you have to connect the battery in such a way that this depletion layer width should increase, it should not cancel out. That means N side should be, so the voltage you are applying should be supportive. That means here should be plus, here should be minus. That means battery should be connected in this way. That means N side is given positive and the P side is given negative. That means it will be the reverse bias connection. Okay, this is a question from your semiconductor part. Now, the last question in our session, look, the energy equivalent of 0.5 gram of substances. Again, as a simple, rather direct, simple question. Okay, look, E is equals to your Einstein's famous relation, E is equals to mc square, and it will be 0.5 gram. It is so 10 raised to minus 3, and c square, so it will be 3 into 10 raised to 8 to the whole square. Okay, so it will be 4.5 into 10 raised to 13. I think 4.5 into 10 raised to option number 2 is your answer. Okay. Hope you are gone through this question part well, and I believe that you are done the examination in a good way. Best of luck your future. Thank you.